Hi viewers, today we'll see real numbers exercise 1E for grade 10 CBSE board. Question 1, state Euclid's division lemma. So we already know, we have already seen it. It's nothing but a and b are the integers. Then there exist two more unique integers q and r, which are the quotient and remainders. So a equal to bq plus r. Here the remainder is definitely less than b. So a is the dividend, b is the divisor, q is the quotient, and r is the remainder. And definitely the remainder is going to be less than divisor. That's where we stop the division. We can take a simple example, 11 divided by 5. So 2 times 10, remainder is 1. So if you see here, the dividend is 11 and divisor is 5 and quotient is 2. So 5 into 2 plus remainder is 1. So that's 11. Next question 2, state fundamental theorem of arithmetic. So the theorem is every composite number, we know whichever is having more than 2 factors are called composite numbers. 4, 6 are the composite numbers which have additional factor other than 4 and 1, which is 2 in case of 4 and 2 and 3 in case of 6. So every composite number can be uniquely expressed as product of two prime numbers except for the order in which the factors occur. Here we can see the example for composite number as 4 and 6 as I explained before, which has more than 2 factors are called composite number. Or the other way is, those which are not the prime numbers are the composite numbers. So apart from 1 and 4, 2 is also a factor of 4. Apart from 1 and 6, 2 and 3 are the factors of 6. So these are the composite numbers. Same way you can see, if product of two prime number, it gives again a composite number. 7 and 5 are prime, which gives a composite number 35, which has more than 2 factors. Question 3, express 360 as product of its prime factors. So we can do prime factorization with two table with prime numbers only on the left. So it's 180, again 2 times 90. So then we can do it with only the prime numbers. We can factorize. So with 3, 30 times, with 3 again 15 times, with 5, 3 times, and 3, 1 time. So we write them as a product of the prime factors. So in this case, it's 2 into 2 into 3 into 3 into 3. 3 times it's there, into 5. So 2 to the power of 2 into 3 to the power of 3 into 5 to the power of 1, or just 5. Next question 4. If a and b are the prime numbers, find the HCF, highest common factor. It's been already mentioned as prime numbers, so which has only 2 factors. For 2, it's 1 and 2. For 3, it's 1 and 3. It's not divisible in any other numbers other than 1 and itself. So 11, 13, it goes on this way, which has only 2 factors, 1 and itself. So obviously, when we take the HCF of the given number, let's assume 2 and 3. 2 goes in 2 table, 3 goes in 3. So it's only 1 is HCF of 2 prime numbers is always 1, as nothing is common among them. Same way between 7 and 13. That's again 13 ones are 13. Question 5. If A and B are the prime numbers, find the LCM of AB. So let's take two prime numbers 7 and 5 just for an assumption. So LCM, if we take, it's just going to be the product of those two given numbers, as again nothing common between them. So LCM is the product of the given numbers A, B. And in this example, if you see 7 into 5, 35 is the LCM. So concepts can be solved with simple examples for better understanding. If product of two numbers is 150, find the LCM. So we know already product of two numbers is equal to HCF into LCM. Product is already given in the question 1050. HCF is also given 25. So we can find LCM, which is equal to 1050 divided by 25, which is 42. So LCM is 42. What is a composite number? We have already seen, which has more than two factors. 1, 2, and 4 in case of number 4. 1, 2, 3, 6 in case of number 6. So the number which are not prime or the number with more than two factors can be called as composite numbers. Or other way, those numbers which are not prime are the composite numbers. In both factor tree and division method, I am showing the composite numbers which is having further factors 1, 6, 2, and 3. Next question 8. If A and B are relatively prime, then what is their HCF? This we have already seen prime numbers. Only one is common among them, as they are divisible only by themselves and 1. If a rational number A by B has a terminating B decimal expansion, what is the condition to be satisfied by B? This we have seen in the previous exercise. So B is of form 2 to the power of m into 5 to the power of n, where both m and n are non-negative integers. Next 10 question, simplify the given number. So 45 can be written as 9 into 5. 20 can be written as 4 into 5 or 5 into 4. Both 9 and 4 are perfect square, so we can remove them from square roots. They become 3. 2 into 3 into square root of 5 plus 3 into 2 into square root of 5. So divided by 2 to the square root of 5. So 2 3s are 6 square root of 5 plus 6 square root of 5 divided by 2 square root of 5. So summing up the numerator, it's 12 square root of 5 denominator, and it goes off. Answer is 6. Question 11, write the decimal expansion of the given fraction. So 73 by 2 to the power of 4 is 16. 2 2s are 4, 4 2s are 8, 8 2s are 16. 5 cube is 125. 16 into 125 is 1000, which can be written in decimal as 0.073. Question 12. Show that there is no value for which 2 to the power of 5 to the power of n and 5 to the power of n does not end with 5. Both are n, so we can multiply 10 to the power of n. And we know that divisibility rule for 10, it is always divisible only by 10, which means only the ones place is always 0. So it cannot have a number 5. If you just recollect the divisibility rule For any given number, one's place is an even number, then it is divisible by 2. If you sum all and divisible by 3, then it is divisible by 3. For 4, last 2 digits divisible by 4. For 5, last number is one's place is 5, so it goes on this way. So that way we confirm it does not have any value ending with 5. Question 13. Is it possible to have two numbers whose HCF is 25 and LCM is 520? So HCF must be a factor of LCM. So in this case, when we take the LCM of 520, so 2 times 260, 2 times 130, then again 2 times 65, then 5 times 13, and 13 times 1. So HCF 25 is not a part of factor of 520. So this is not possible. Next, question 14. Give an example of two irrationals whose sum is rational. This is we have seen in previous exercise also. So let's assume two irrational numbers, 1 plus square root of 2 and 1 minus square root of 2. So when we sum up, when we add them, minus and plus square root goes off. So answer is 2, which is a rational number. So it is not necessary to always be irrational when we sum two irrationals. Same way, question 15, the product is again rational. So let's assume two irrational numbers here, 5 plus square root of 2 and 5 minus square root of 2. This is of form a plus b and a minus b. So formula is a square minus b square, which is 5 square is 25 and square root of 2 whole square is 2. So answer is 23, which is a rational number. So product of two irrational can also be rational number. Question 16, if a and b are prime, what is their LCM? So from the given question, which has already been mentioned, HCF is 1 for prime numbers, we already know. So, and also we know product of two numbers equal to HCF into LCM, and HCF is already 1. So which clearly show LCM is going to be the product of the given number, in this case A and B. So AB is the LCM. So LCM is product of the given two numbers A and B. Question 17, LCM of two numbers is given. Show that the HCF cannot be 500. HCF must be definitely divisible by, exactly divisible by LCM. So as per Euclid division lemma, we can just try it out. 1200 is equal to 2 into 500. As it's mentioned, 500 cannot be HCF, but it has a remainder of 200, which is not equal to 0. So that clearly shows 500 is not the HCF of that. Next question, 0.4, which is non-terminating and repeating number. So let's assume it as x, and 10x is 4.4. So by taking these two as equation 1 and 2, we subtract. So 10x minus x is 9x on the left hand side, and 4.4 minus 0.4 is 4. So x is 4 by 9. This is a simplified form. Next, 19 is 0.23, which is non-terminating and repeating number. So let's assume it as x and equation 1. Then 100x is 23.23. So again, by subtracting 1 and 2, we get 99x equal to 23. X equal to 23 by 99, which cannot be further simplified. as 23 is a prime number. Next, express why the following number is irrational. We know irrational meaning they are non-terminating and also non-repeating numbers. So here if you see 150, then 1500, so it goes on in a non-recurring pattern or fashion. So that shows that this is an irrational number. Hope it is useful. If you find this useful, please do share and subscribe. Thank you.